Good morning, good afternoon, or good evening, depending on where you are, and welcome to the Nautel webinar, All Digital AM in the Real World. I'm Chuck Kelly, I'm your host in this webinar, and I'm delighted to be joined by an all-star, rock star cast of characters, of people that are going to share wonderful information with you today. If we have a problem today, folks, it's that we've got so much information from so many smart people. So we will try to keep it moving, but you're going to have to tighten your seatbelt and hold on because we're going to be moving. I want to introduce our guest, Mr. Dave Colasar, as a senior broadcast engineer with WTOP and WFED. Welcome, Dave.
Hi, Chuck. Thanks for having me.
Nice to have you. Mike Raid is a senior manager with broadcast technologies for Xperi Corporation. Mike?
Hello, Chuck, and everybody out there. Glad to be a part of this.
Thanks, Mike. And Roxandra Brija is the chairman of the DRM Consortium, joining us from London. Hello, Roxandra.
Hello, everyone, wherever you are.
Nice to have you with us. And Joshua King, project engineer for Kintronic Labs.
Good afternoon from Tennessee.
Thanks, Josh. And last but not least, Mr. Philip Schmidt, one of the visionaries of Nautel, a research engineer. Welcome, Philip.
Thank you.
Okay, that didn't sound so wonderfully. Hopefully your internet connection is going to be working a little bit better. So we're going to talk about a few things today. Why all digital AM? We're going to talk about a specific instance of a landmark first station in the nation to put on all digital AM with WWFD. We're going to talk about the future vision from Xperi and from DRM. Both technologies support all digital AM. What about the antenna? We're going to talk about the things you need to think about if you're going to have a medium wave or AM station using all digital AM or digital AM of any type, even hybrid. Attributes of an ideal AM transmitter for all digital. And then finally, we're going to take your questions. And you'll notice, if this is your first time using this GoToWebinar application, that there's an area for you to ask questions. And if you click on that area, you can type in a question, and near the end of the webinar, we will do our darndest to answer all your questions. If we are not able to answer all the questions, we will get back to you by email afterwards with the best answers we can come up with from the assembled guests here. I will mention to you, we're quite proud that the completion of a Nautel webinar qualifies for half of an SBE recertification credit identified under Category 1 of the recertification schedule for SBE certification. So with no other information, let's talk to Dave Colasar. And Dave, tell us what happened at your radio station.
Thanks, Chuck. What must be said first and foremost is that All Digital AM is a cooperative project between many industry players. I'd like to thank Hubbard Radio, my employer, for allowing me to do this, Xperi Corporation for their expertise and assistance that made this project possible, Kintronic Labs for their antenna system modeling, and Cavell Mertz and Associates for their time and expertise, particularly Gary Cavell for his advice and work on our experimental authority. I'd also like to thank the manufacturers for pushing the art of all digital AM forward, Nautel, BE, and Gates Air. I'd also like to thank Potomac Instruments for their expertise and NAB Pilot for their assistance as well. Next slide, please. To start, the most obvious question is, why do this? The limitations of analog AM broadcasting are well known. Poor audio quality, noise, and lack of compelling metadata accompanying the transmission. And that's something that's now expected by most modern users of media. The first step towards leveling the playing field for AM broadcasters was operation in the hybrid, which is also called the MA1 mode of HD radio. This technology allowed simultaneous transmission of analog and digital signals while providing backward compatibility with existing radios. However, it was accompanied by some disadvantages. The audio bandwidth of the analog signal had to be reduced to 5 kilohertz, and the primary digital carriers were restricted to 30 dB below the main analog signal so as to keep self-interference to a tolerable minimum. This compromise severely limited the range and robustness of the digital signal and also degraded the quality of the analog signal. both of which were issues that prevented universal industry acceptance. An all-digital approach to AM broadcasting is appealing to a station such as WWFD for a number of reasons. First, with the acquisition of an FM translator, the core of the analog audience in the city of license is already served. Second, the higher throughput of the all-digital mode of HD radio makes it useful for music transmission, such as our adult album alternative format. Finally, the digital carriers of the MA3 HD mode are much higher in power, so signal robustness is drastically improved, making the transmissions viable for in-car listening for the duration of long commutes after the FM translator has faded. Xperi has estimated that about 22% of cars on the road in the Washington, D.C. area have HD-capable radios installed. More listeners are likely to be counted from this percentage who can receive the signal with excellent sound quality and metadata, album art, titles, artists, then of course from the vast majority who can receive the analog transmissions, but who would likely refuse due to the poor quality. So next slide, please. What we see here is a picture of off-air reception of WWFD. Note that in addition to the frequency, which would be the only item displayed with analog transmission, you see the call letters, artist, title, album, and even album art. This is not possible with the hybrid system. It is evident that AM broadcasters with the MA3 mode achieve aural and visual parity with other services in the dash, such as FM HD, satellite, and streaming services. This is a big leap forward. Next slide, please. Let's take a look at the facility itself. Having first signed on the air in 1961 as a 500-watt day timer on 1370, WWFD was converted to a full timer on 820 in 1987, which involved a phaser rebuild, reorienting the towers, and adding some top loading. So as you can see, there's been a lot of changes at this facility, and the transition to all digital is a continuation of that. Next slide, please. What's involved in taking the station all digital? First, the antenna system must be looked at. It was found to be inadequate, not having the required 1.4 to 1 SWR over the digital passband, and that, of course, is a rule of thumb. This meant that changes needed to happen. Also, the transmitters need to be evaluated for all digital operation. And lastly, the regulatory aspect must be handled. And we'll take a look at our sign-on and initial test results. Next slide, please. The antenna system was the first area of focus. Document everything is the first step. Schematic diagrams were updated, component values were measured, as well as the self and drive point impedances. With this data in hand, modifications were suggested. In addition to this redesign, there are also some sins of neglect, which are typical of what might be found at many older US AM transmission sites that, of course, had to be remediated. And Joshua will talk about this process in more detail. With the day and night networks modified and tuned up, the antenna system is back into adjustment as per the station's license. Next slide, please. As part of the digital transmission conversion process, the transmitters previously used for analog broadcasting at WWFD were evaluated for digital capability. We determined that the main transmitter, a Harris Gates 5, could be modified for HD. However, some fairly extensive hardware changes would be necessary. It was determined that the most expedient path to digital would be to replace the device with a new Broadcast Electronics AM6A transmitter. The Gates 5 could then be modified as time permitted for use as an auxiliary transmitter for the digital service. And of course, with the AM6A transmitter, we're using a Nautel AM IBOC exciter, the Exporter Plus, and the Multicast Plus box in importer mode. A big addendum here that I'd like to mention is that we will be installing a new Nautel NX5 transmitter so that we may examine the performance of a transmitter designed to handle MA3 operation out of the box. We are excited to test this, and a report on our results will be forthcoming. Next slide, please. With assistance from Gary Cavell at the Cavell, Mertz & Associates engineering firm, a request for an experimental authorization of the station was drafted and submitted to the Federal Communications Commission. Next slide, please. So, at noon on July 16th, 2018, WWFD commenced all digital broadcasting, becoming the first, and for now, the only U.S. medium wave station to do so. For the curious, the first song aired after the digital-only switch on was the Electric Light Orchestra's Calling America. Spectral emissions were checked again, as well as base currents and directional parameters. Once we were satisfied that the station was operating within licensed parameters, it was time to evaluate the over-the-air performance with some automotive drive testing. Next slide, please. Daytime drive testing revealed generally robust reception to the station's 0.5 millivolt per meter signal contour. And of course, this is generally accepted to be the limit of useful analog coverage for a US AM station. Under ideal circumstances, we found that digital reception out to the 0.1 millivolt contour is possible. And that, of course, is well beyond any listenable analog signal. During critical hours, reliable reception may retreat back towards the 0.5 millivolt contour, even under ideal conditions. During both day and night operations, no dropouts were observed while driving through the urban core of Frederick, Maryland, the station's city of license, and such observations bode well for indoor reception in this area as well. Next slide, please. The primary unresolved technical issue observed with the present WWFD transmitter configuration is the inability to generate sufficient carrier-to-noise ratio to reliably allow the secondary MA3 carriers to be properly decoded by the receiver. While not severely impacting audio reception, it can affect the ability of the receiver to provide enhanced user data services, such as the display of album artwork. The lessened carrier-to-noise ratio may also slightly increase the time required for an HD radio to lock onto the MA3 signal. In consultation with both Xperi and the transmitter manufacturers, its cause is being investigated with a fix hopefully forthcoming shortly. The Nautel NX5 will provide album artwork and faster acquisition out of the box, and we look forward to showing off the enhanced capabilities of MA3 broadcasting very soon. Other future work includes more testing to document the useful coverage of the signal, especially when noisy environments are encountered. As the WWFD experiment shows, broadcasters are willing to take innovative steps to keep legacy platforms such as medium wave radio relevant and competitive. A digital future for medium wave broadcasting is on the horizon, and such a future will help ensure that services in this portion of the spectrum are both included and desirable in automotive receiver menus. Thanks.
Dave, thank you so much for sharing your history-making developments there. I really do believe we're seeing history made. A couple of questions for you. One is, how long do you expect to be doing this?
Well,
it's a temporary license, right?
Yes, we have experimental authority for 1 year, although we have much more work to do, so we intend to have the authority renewed. And in my mind, we are digital from here on out. I believe that we should stay digital, and I believe as we continue to operate in this mode, more and more people are recognizing the benefits of this mode of broadcasting.
Do you have any customer comments of people that have suddenly started hearing you in spectacular audio quality and are wondering why?
Yes. In fact, shortly after the transition, I received a number of messages from listeners who had been listening to our analog AM signal, and one day commented that it was clear all of a sudden. What did we do? So these people weren't even aware that they had HD radios.
Cool. Any effect on the advertising environment of your station?
Not particularly, especially since the risk to the station is reduced with the addition of the FM translator. The translator covers the city of license very well, and much of the audience had migrated to the translator when we put it on the air. And as a result, we believe that the expanded coverage of the all-digital AM signal will actually help us increase our audience because this audience will now be able to hear our music programming in a sound quality that they want to, rather than us fighting the losing battle of trying to convince people to listen to analog AM.
Fascinating, Dave. Thank you so much. And now we move to the perspective of Xperi Corporation. Mr. Mike Raid has joined us.
Yes, thank you, Chuck. Appreciate that. A transition to all digital radio and how we envision this is, what would help AM stations to be able to do this. Number one, I think particularly FM translators would be a factor. More than half the stations, AM stations in the United States, currently have FM translators for their analog AM signal to help with that, and that certainly could be used to help transition listeners to who have analog currently or analog only radios currently to help keep the station viable. WWFD is definitely the pioneer in this. They are number one. And as Dave mentioned before, they approached us at CES, and we were very enthusiastic and very engaged in the process, and did whatever we could do to help. So right now, currently, as they said, they're AM all digital. They intend to stay all digital, and we're going to certainly help to keep that vision going. With the FM translator still in place for WWFD, but Xperi certainly encourages other stations in similar circumstances, i.e., have a translator with their station, with their analog, and other ways of communicating that to transition to all digital. We've learned a lot in the process, and we certainly would be more than willing to help anybody and everybody who wants to become number 2, 3, 4, 5, possibly in the future. So, next slide, please, Chuck. The potential of all digital, as you can see by the picture, it's breathtaking. First off, it's a stereo audio, free from fading and noise, no static. Secondly, program service data. Analog AM has no way of transmitting currently. Mono AM certainly has no way of conveying any artist and title information. With HD radio and any, in particular, or for that matter, any digital platform has the ability to transmit this title and artist information and album information. Data services that are going to be on par with FM. What we mean by that is if you have an HD signal on FM, you now are on par with that FM signal running AM all digital. You can run artist experience, you can run your station logo, quite possibly even traffic and other data services that run in the background. Certainly also emergency alerts, and this has definitely grabbed the attention of the FCC here in the United States, to be able to transmit emergency alerts on the receiver, and that is, radio's bread and butter, especially AM radio's bread and butter is emergency communication. And with MA3, the emergency alerts feature enhances that. What that all entails, now that you've seen this and see this on the receiver and on the picture, this demonstrates not only to broadcasters, but to radio manufacturers, receiver manufacturers, mostly automobile manufacturers, that the broadcast industry in the United States and in North America is still innovating. That the broadcasters care very much and very deeply about the frequencies that they have, and they're willing to invest and innovate moving forward in their infrastructure. Next slide, please, Chuck. So the potential, there's almost 60 million radios out there in North America currently right now. The good news is those radios that are AM equipped to receive AM and receive HD radio, either in the MA1 mode or FM, are MA3 capable. We certify every radio that comes through, and if it works with MA1, it also has to work with MA3. It is required to do that. And also we've listed for people who wish to download the presentation later, the top 10 radio markets in the United States and their auto penetration. And currently New York and Los Angeles are certainly leading the way. So with that, Chuck, I turn it back over to you.
Thank you so much, Mike. And now we turn it over to Roxandra Obrija. You know, DRHD radio is only part of the story of all digital radio around the world, and DRM has been leading the way in many parts of the world. Roxandra, welcome.
Thank you very much, Chuck, and thank you very much for welcoming me, because I was starting to feel a bit like a DRM cuckoo in an HD nest. But that's not the case at all, and I can see a lot of similarities. But going to Digital Radio Mondiale, as you can see, the standard can do absolutely all the bands below and above 30 megahertz. But it really started as an AM, HF and AM replacement, superior replacement to analog, and it started right from the start as a digital only, as a replacement, as a flexible solution. Next slide, please. And you've heard just a couple of minutes ago about some of the great benefits of digital radio, no matter which standard. I will, in a way, repeat some of them, but they are very specific to DRM, and I will home only on those specific ones. First of all, it's the spectrum usage that allows DRM station to offer on one single frequency up to 3 programs and the data channel. All the 3 audio programs can also be accompanied by data. That's extraordinary if you think of it, and it gives possibilities to stations both to get more ad revenue, to regulators to give out more licenses, and to enrich the whole radio ecosystem. Excellent audio. I think AM in digital, in DRM, is a completely different animal. Forget about crackly shortwave or medium wave. Multimedia applications, again, it's aligning radio with everything we see around us in the digital world. DRM offers also great possibilities through single frequency networks, so using the same frequency, and it offers automatic tuning, no more frequencies, and like HD, has the possibility of becoming an emergency warning, an alert device, and that is very, very attractive to a lot of countries in the world. Next slide, please. The one thing I haven't mentioned specifically was the energy consumption. So apart from being a very flexible system, apart from offering more channels, more programs on one single frequency, and don't forget the bandwidth is 9 to 10 or 1820 kilohertz, it also offers the possibility of giving good, excellent audio coverage using, in this example, about a third of the power and 3 times more programs. This is an extraordinary efficiency and also a reduction in energy costs. So digital is not just about sound, but it's also about long-term investment. Next slide, please. And so I'm not going to read the whole slide. You can read it yourself. But DRM standard for large area coverage actually gives the AM bands a new lease of life. It can be introduced gently. It doesn't need a completely new infrastructure. It offers the energy saving. I just gave you the example of more than 60%. And it's also already in the industry. I mean, Nautel knows it better than anyone because they do medium wave transmitters which are all over the world. Next slide, please. You will have heard a lot about the US. Very interesting. Here are just some of the key countries where DRM is being deployed. As you can see, Asia and Africa especially are growing markets for us, a little bit in Latin America and in Europe as well. Next slide. The largest digital radio deployment to date is in India. Look at the power that is pumped up in the air every week. And the 600 million people, about twice the population of US, which is in the incidence of DRM signal. Next slide, please. It's, as I said, not only about flexibility, good audio quality, extra services, multimedia services. It's about emergency warning as well. And I'm very happy to say that we have tested that on air, and we have shown how this can fit very well. We tested it with 2 programs on air, 2 audio programs on air in New Delhi, and how the emergency warning could be very well fitted and give the disaster warning using the CAP protocol and really convincing the Indians that that's the way to go. Next slide, please. Of course, it's all about receivers, not 60 million like in the US, about 1.5 million in India, which is remarkable in 18 months. It's sure that cars are driving digital radio, no matter which standard, and this is happening in India by large, the biggest surprise we've had in the consortium. Line fit receivers, analog and as well as digital, with all the information on the screen. And what do the Indians think about it? They are delighted because they don't pay anything extra for the line fit receiver. Next slide, please. And this is really just to bring everything together, and I'm not going to repeat everything I've said. Benefits for audiences, more choice, benefits for governments and regulators, more services, good country coverage, and additional revenue streams. Of course, broadcasters have more to play with. They can offer more improved services and also make use of their AM infrastructure. I would say just one thing here. Lots of people are thinking of giving up on AM. You give up AM, you will see what happens. You will never get that frequency back. And there are a few countries in the world that will snap it. See what's happened in Australia and the debate there about reinstating shortwave. So digital AM is a new animal. It links to the internet without data plans. is a new digital platform. It brings people in the environment they are used to through mobiles, through digital television and other gadgets. And it future-proofs radio. I really believe that. I've written about it, and I strongly believe that AM digital is not dead. It is different. It's transforming itself in a completely different thing. And in the future, I don't think our listeners will know whether they are listening to digital FM or digital AM. They will just want the good quality and all the services they expect from us. Thank you
so much. Thank you so much, Roxana. That's great. I really appreciate all of your thoughts. And of course, there's the information where they can get more information. The DRM handbook is online at drm.org.
Yes, and it's free.
And it's brand new. Perfect. Okay. By the way, we're going to archive not only the video presentation with all the audio and everything, and that should be up within 24 hours or so, but we'll also have a PDF version of all these slides, and all the hyperlinks are going to be clickable. So if you see hyperlinks going by and you want them, don't worry, you can download that and get to them right away. Okay, next but not least, Josh, welcome, and tell us about the antenna challenges, I guess.
Hi, Chuck. Thanks for having me. So I'd like to highlight the importance of the antenna system, and I'm going to start by talking about some of the goals we have in mind when we design antenna systems for digital operation. So the table on the left shows bandwidth guidelines we like to keep in mind when designing or transitioning a system to digital operation. The diagram on the right is a Smith chart illustrating the Hermitian symmetry of the impedance bandwidth we want to see measured at the output of the transmitter. These guidelines are important because if the load impedance characteristics are not symmetrical, this can complicate the error correction process and erode the reliability of the digital transmission channel. It's more important for antenna systems designed for digital operation to maintain really good bandwidth so that all the energy in the side bands which contains the data needed by receivers to reconstruct the digital signal makes it through. This can help with less blackouts or regions where you can't get the signal. So typically when we design a system, we look for VSWR less than 1.05 at plus minus 5 kilohertz and less than 1.2 at plus minus 10 kilohertz and plus minus or 1.4 at plus minus 15 kilohertz. And at that point, we consider the system to be rotation independent. So you don't necessarily have to have that perfect Hermitian symmetry. The next slide, please. So this is just to illustrate that we need to consider the whole system. This is key to get the best digital performance out of your antenna system. So working back from the antenna, we need to consider the tower and mast characteristics. Is it a guide tower? Is it a self-supported tower? Is it series fed or is it skirt fed? If it's skirt fed, we need to know complete design details. Take into consideration the matching networks, the phasers, your IMUs, your ATUs, and the phase shift associated with each of those networks. The feeder system, so your coax from the transmitter to your ATUs or what have you. And the exciter and transmitter also need to be considered because the output filter network has a certain phase rotation associated with it. Next slide, please. This is just an example of a directional antenna system, and we can go on to the next slide. All right, so I'd like to discuss some tricks and tips to improve the bandwidth of your system. There's a lot of information here. And if there's one thing or one point I'd like to get across, it's that it's not that difficult to transition your system to digital operation. It's probably easier than people think. This is a lot of options, and maybe just one of these things can be used to make your antenna system ready for digital operation. So next slide, please. So top loading. Towers with narrow face widths and electrically short guide towers typically have narrow bandwidth. If you add top loading, this can improve the bandwidth. It's like stretching the tower, and it makes it electrically taller without making it physically taller. And it's a cost-effective way to do this. Next slide, please. The rhombic skirt makes towers seem fatter than they are and can yield optimum normalized impedance characteristics for digital broadcast. They are particularly useful when you're multiplexing multiple frequencies on a single tower. Next slide, please. Folded unipoles. These need to be designed well because a good unipole can really improve your bandwidth, and a poorly designed unipole can hurt your bandwidth. These are also useful for putting other equipment on your AM tower, whether that's cellular infrastructure or what have you. Next slide, please. Phase rotation. This can be as simple as adding a single element like a capacitor or inductor. Sometimes you need more control, and you can add a full T network or an L network to get that extra control of the match and phase rotation that you need. Next slide, please. Some frequently used methods for sideband impedance improvements are slope correction, pre-matching, and cascading networks. Can you go to the next slide, please? So over on the left is an example of slope correction in that input branch, and on the right you can see an example of pre-matching on the top and cascading networks on the bottom there. Next slide, please. One thing we noticed at WWFD was that the filters weren't tuned correctly, and this really affected the impedance of the overall antenna system. So check your design of your filters and the tune of them. And then we also found that some transmission line had been bonded to the tower and was affecting the impedance. This won't necessarily improve your bandwidth, but it will help you have a better understanding of what impedance you need to match to. Next slide, please. Lastly, I've just posted some links here to some tools that we recommend when troubleshooting your antenna system or tuning it. And if you download the webinar, you can access those links. And lastly, I'd just like to say that we're here to support all the efforts to transition your new or existing broadcast station to all digital operation.
Josh, thank you so very much for sharing all your expertise with you. I know we could have gone a lot longer and gotten into a whole lot more detail, but I think it's very helpful to all the listeners. Thank you.
Yeah, thank you for having me.
Last but not least, we have Mr. Philip Schmidt from a visionary of Nautel's design department who has really changed the world of HD radio and DRM in as far as Nautel's implementations. Phil?
Well, thank you for the kind words, Chuck. I want to spend a little bit of time talking about our NX transmitter line and how it is optimized for digital operation. I was quite involved in the exciter design of the NX, so I can talk to some of the aspects there. First thing I wanted to show you is the versatility of the design, and that's really well demonstrated with DRM here. So I'm showing 3 signal configurations here. The left one would be a 9 kilohertz DRM. The middle one is a simulcast of the AM signal along with a digital component. And on the right-hand side is an 18 kilohertz wide signal. And the reason why we are quite versatile and flexible in how we can handle signals is that all these signals are fed into the transmitter using a digital IQ input. We've repurposed an AES input to, rather than carrying audio, it can now also carry essentially a digital IQ baseband representation of the signal, and we're somewhat agnostic to what the actual signal is. And then from there on, we make sure that we amplify the signal as cleanly and best possible way. And I'll talk a little bit about some of the pre-correction techniques that we employ. So next slide. So by the same token, we do have an input for the HD signal as well. What's different with the HD is that we have an integrated XGen card, which is the HD modulator. And it internally feeds the IQ signal over the same kind of serial link as the external DRM modulator through the AES input port using a serial port. And with that, we can broadcast both the hybrid MA1 waveform shown here, which gives you about 20 kilobits of what's called core bandwidth, and then 60 kilobits of enhanced bandwidth that allows you to get better audio fidelity and quality. But we can also do the all-digital MA3 waveform. One thing to maybe highlight here, and it's pretty nice to see in this picture, even though we have lots and lots of mask clearance, you can see the spectral regrowth of the hybrid waveform. Gives you these sort of humps that we see in FM as well. But the all-digital waveform, because all the carriers are sort of grouped together, is more of a skirt. So that's a little bit of a difference to what people might be familiar with in HD. So next slide. What's important to note is that with all digital transmission, we need to rethink how we measure power. It really has to be RMS power. Your typical averaging meter used for AM operation, of course it works great for AM, and it didn't introduce too much of an error when we're running hybrid mode because of the low injection of the AM carriers, the HD carriers rather. But once we get into MA3, it can introduce a very large error. And the other thing to note there as well is that the peak power of the all-digital waveform is much, much higher than the other waveforms. And as such, what Nautel does, during normal AM operation, we give you the averaged power of the signal, but for all digital operation, we display the RMS power as we measure it in the transmitter. So keep that in mind when you're sizing transmitters. We're not exactly talking apples to apples here. Inquire about what the RMS power capability of your transmitter is. Next slide. Some of the other measurement tools that we provide you with here, and one thing that didn't make it on the slide here is we also have a Smith chart that we can also provide on a transmitter to give you those cusp rotations that we just heard about. And that's unique because we have both a voltage and a current probe in our transmitter that allows us to do that. But we also have a built-in demodulator in our transmitter. So you can see the signal constellation on the left. That's the MA3 waveform here, but it's broken out into in the center block. There would be the reference carrier on the inside. Then there's set of data carriers, the PIDs carriers, and then more data carriers. But you can see even the lowest level of those carriers still have an excellent MER of over 37 dB. Now all of this is of course into a dummy load, but even on air we can get very, very good results there as well. But it allows you to troubleshoot some of your transmission systems by looking at what the carriers are doing across the band here. And of course we have our spectrum analyzer as well. Now some of the features or some of the things that we do to make sure that we broadcast the cleanest signal possible is we offer several correction factors or pre-corrections. The very basic one, of course, that we're quite familiar with is the mag phase delay. As shown in some of the block diagrams earlier, the NX transmitter also operates on magnitude and phase. Our input may be IQ or a number of inputs, but internally we then break it into an envelope component and into a phase component. And in order for the signal to be combined properly in the power amplifier, the two delays need to be matched perfectly, and that depends on loading. So that's a number that you have to tweak a little bit and to optimize the spectrum. The next set of corrections that we do is what we call AM to AM, which looks at the magnitude linearity of our amplifier. And it looks at the input level of a signal and ensures that you get the corresponding output amplitude level. And you can see that in the left bottom quadrant in this display. It analyzes the entire dynamic range of the amplifier, and if there's a correction needed, and it's typically in the low end of the amplification, then it will apply a correction curve. In particular, for all digital, that's an important point to note. AM will never cross zero magnitude. We'll get really close. We can get really, really deep troughs, but it never actually crosses zero. All of the HD standard or all of the digital standards will frequently cross zero. So it is very important that your transmitter is very linear in that lower range, particularly towards zero in that graph. So it's very, very important that that is characterized quite well, and we certainly do that. By the same token, there is typically a phase error that happens with amplitude. We can correct for that as well, and again, that is a more of a lower magnitude aspect or issue. You can see that in the lower right-hand corner. And again, typically for AM broadcast, it's not such a big a deal because you don't typically spend a lot of time at low magnitude. But with all digital, again, we're crossing zero all the time. Another correction that we do is on the magnitude path. We look at the frequency response of the entire path, and we have an adaptive algorithm to figure out what the errors are, and we'll correct for them accordingly. We also look at our supply voltage, and if there's any sort of short-term variations due to signal peaks, we can compensate for that as well. So yeah, we've got a lot of these things, and I think that is what makes our transmitters one of the best ones on the market. One thing that's kind of new is that even in Dave's block diagrams earlier, we've shown the separate importer and exporter. Well, we can now collapse those two components into our HD Multicast Plus product. That's already quite well adopted on the FM side of things, but we've been able to make it work for AM as well. So I think that this will be an attractive option for some of the all-digital broadcasting modes for HD, as it already comes pre-configured with station logo. You can see here I've put our Nautel logo and managed to send it over to a receiver. It's also integrated in the software. And we'll also support artist experience. And maybe at some point when we're ready, it may be possible to put an HD2 on the air. So I think that's a useful tool in your toolbox moving forward, and hopefully it will help more stations to adopt all digital in the AM band. Well, thank you, Chuck. Back to you.
Thank you so much, Phil. Unfortunately, I think we've gone kind of long already, so I'm not going to be able to get to too many questions. Let me see if I can answer one or more of them, and then we will answer the other questions via email. Alan asks, when you switch an NX transmitter for AM to all digital HD radio, what happens to the transmitter power consumption? Phil, would you like to address that?
Sure.
Hello, Phil?
No, I'm unmuted. There we go.
Okay, there you go.
I don't have the exact efficiency numbers in front of me here, but it is still, we're a PDM-based architecture, and it is very, very efficient in all of these transmission modes. But the one thing that you do need to realize, like I mentioned, is that essentially if you're used to measuring the carrier power, you will have to, if you measure it against the carrier, it will have to be backed off, like we saw earlier. 50 kilowatts in NX50 that is quite happy with 50 kilowatt AM, that carrier that's part of the MA3 will have to drop to about 19 in order to support the increased peak power consumption. So, overall, I think efficiency-wise, it's still good, but you do need to ensure that you size the transmitter for all digital operation.
Perfect. Thank you so much. We have a question from a good friend, David. He asks, question about DRM. What is meant by automatic tuning retunes? Roxandra?
Sorry for taking time. That was not for thinking about the answer. This was simply to unmute myself. What it means automatic, it means that the screen of your receiver will show your station. If your station is Love FM or Love Radio, it will just say Love Radio. It won't say, or St. Valentine's Radio. It won't say St. Valentine's Radio 780 or 141.9 or something like that.
Frequency becomes irrelevant.
Sorry?
The frequency becomes irrelevant.
Absolutely irrelevant, and the way it's done in the background is that, of course, each station has a unique number, it is registered, and then the transmitter sends the information. So all that is done automatically in DRM.
Excellent. Thank you, Roxandra. Last question I'm going to answer, and we've got 10 times more questions that will need to be answered in the next couple of days. But Phil, can you tell me about the effects of MDCL on all digital radio? Can it be used at all?
We certainly have it supported for hybrid radio. I mean, it really doesn't make that much sense in all digital because your AM is gone and it's dependent on your AM modulation.
That's correct.
But certainly, yes, we do support it for all digital, for hybrid, the MA1 waveform.
Right.
And the reason we do that is because we can inject the analog audio separately from the HD stream, and then from that learn what the carrier power should be. And we do certainly see significant savings from that.
Excellent. Okay, folks, well, we've overrun our program length by about 5 minutes. I appreciate everybody for sticking around. We had a huge audience, and it's obvious to me by the questions that we've got here that there's a tremendous amount of interest in this topic, and we're so grateful that all of you have been here to have a webinar and some education on something that the world thinks is as mundane as AM radio. So thank you so much. Thank you so much for our presenters for sharing all of their experience and knowledge with us. Thanks to Dave Colasar, Mike Raid, Roxandra Obreja, Josh King. I am so grateful, and of course, Philip Schmidt from Nautel. All these links will be available, and you can click on them in the PDF version, which will be going up on our website soon. So for all of the presenters today, for all of the employees of Nautel, thank you so much for being a part of our webinar today, and have a good day. Bye-bye.
Thank you for having us. Bye-bye.
Thank you.
Thank you.
Thank you.